Now we're going to start writing our best fit lines. First way we're going to learn how to write a best fit line is to use 2 points. So we're going to use 2 points on our graph to create a line of best fit. That means we're going to use point slope form to create our line of best fit. We will learn other methods. The one that we're going to use most often, especially outside of a test or outside of a classwork assignment, is going to be to use the computer. But first we want to start off by using our point slope form and applying that to our line of best fit. So when we look at our data, we first would look at positive slope, negative slope, or does it have a slope at all? Do we have a linear relationship? When I look at this data, I would say I could draw a line through it. I would say it's a pretty strong negative relationship. So my line should have a negative slope. Then I'm going to take a ruler, and I'm going to place my ruler in here, and I'm going to try to figure out about where can I place that ruler. And notice how I'm moving this, I'm altering my slope to see how it's going to best match that data. Remember, we're trying to minimize the vertical distance. So I would eyeball somewhere around here. Now, all of us could come up with different lines, but this is the one I think kind of fits my data. So I'm going to plot points where I've laid, and I want to plot points where I can see where those points are going to be. So these 2 red points are going to be the data values. So I'm going to pull this back and I'm going to take a look. My x is 14 and my y is 12. And here I have an x of 4 and a y of 16. So I know to write my line of best fit, oh, I'm sorry, I should have that drawn in there. Connect my points to draw in my line. Now once I have that drawn in there, I'm going to try to write my line of best fit by using my point slope form. So y minus y1 equals m times x minus x1. I'm going to plug in my x1 and y1, and I also need to find my slope. So I'm going to get my slope over here. y2 is 16 minus y1 is 12 over x2 is 4 minus x1 is 14. So 16 minus 12 would give me 4, and 4 minus 12 would give me negative 10. So that would give me 2 over negative 5 for my slope. So I have y minus y1 equals m, negative 2/5. X minus x1 is 14. Now I'm going to find my y-intercept here and my slope. So I'm going to change this to be in slope-intercept form. So the first thing I have to do is distribute this. And I get y minus 12 is equal to negative 2/5 x plus 28 over 5. Not a nice fraction, but that's what happens when we're dealing with real data. Now I'm going to add 12 to both sides. That's going to give me y equals negative 2/5 x. But now I need to add those fractions. I'm going to do a little bit of that scratch work over here. 28 over 5 plus 12 over 1. I need a common denominator. My common denominator would be 5. So I'm going to change this to 5, which means I multiplied my denominator by 5. So I also have to multiply my numerator by 5, which would give me 60. So I end up with 88 over 5. So this will be plus 88 over 5. So the y-intercept of this line is 88 over 5. And the slope is negative 2/5. That means our line of best fit is y equals negative 2/5 x plus 88 over 5. To interpret the slope, you have to keep in mind that our slope is the rise over the run. So we have our rise over our run. Now look at our data. We are looking at TV watching and test scores. So test scores is our y. So this would be test scores.